Aha. Project 667 Bravo Murina Delta I SSBN. After they're upgraded, they'll have Murina M for modernized after that. But they'll go through a midlife upgrade that we'll talk about on or about 1978, going into the early 80s. So this is almost like the tale of two submarines, where they have the original R-29 missile, that I'm getting ahead of myself, and then they have the R-29 Delta, which is an amazing upgrade for them. But here you can see a lot of the free flood area. Look at the water coming out of the vents along the sides of the hull, along the sides of the missile compartment. This is a double-hulled submarine, and you can see where they have these vents that allow the water to flood in. After they submerge, it fills up with water. All right, so second generation project of 667 Alpha, the Yankee SSBN. Those of you that have been members here a while are familiar with my Yankee SSBN lecture. It was a very long, over 2-hour series talking about all the Yankees. This is a continuation of that same project. It is the same type of submarine, it is a Type 3 nuclear submarine. And it is not the same class. So it's a different class, same type. And the difference there is in the weapon systems and navigation, and some of the internals of the submarine make it a different class. But what makes the Yankee and the Delta the same type is that they both use the same engine room. They have the same, reactor, steam generator, reduction gears, planetary system, reduction gears, and they have 2 shafts. It doesn't matter what screw blade is, that can be different, but the shaft to steam generator, as long as that is identical, then it's the same type of submarine. And this is a Type 3 nuclear ballistic missile submarine, as is the Yankee. Okay, so a reliable sea strategic nuclear missile system has been installed on this, called the R-29 and R-29 Delta. It's based on Project 667 Alpha design. They just improved some sound silencing features, which they will do in every generation of the Delta. The missile system is based around the RSM-40, which is the project name for it, or the vehicle name. The NATO name was SSN-8 Sawfly. The Sawfly Mod 2 came out after 1978, which gave it greater capability. That Mod 2 is also called R-29 Delta. I know I'm throwing a lot of names at you. It's all the same missile with an improvement that happens after 1978. That's all you need to know. Okay, missile engineer McKeeve designed the 2-stage missile that could correct its course mid-flight. This is the first time the Russians are doing this, and I suspect they might have beat the Americans to this. The Americans were able to do that too, I believe, in the Polaris missile project. And if they could, then it's about the same time that this is going on. But the ballistic missile first booster phase gets it out of the water and up, into towards low Earth orbit. The second phase takes over after that, carrying the missile body fully into, well, it's not even really an orbit, it's ballistic, right? So it's pre-orbit. But during that phase, it makes a fix on the stars. So it looks for key stars that it knows where to look. And if they're not where it looks, or if it's not where they expect it to be, it can do a mid-course correction so it aligns with specific stars and make sure that they're on the right bearing. And that's how it does this course correction. It doesn't look at the Earth at all. It looks skyward after it's up in, suborbital flight. And it's a greatly reduced missile launch time as well. So what they did was they automated the missile tube preparation. That was on the Yankee, that was done manually, and it took a long time, like upwards of 20 minutes getting tubes ready. And that was very noisy evolution. It gave away their position. Well, now they have a fire control system that pressurizes the tube, prepares it for launch, opens the hatch, has the ejector ready to go, ejects the missile, and then afterwards closes the hatch, drains the missile. That's all automatic now. That's all done by the computer now in the Delta. All right, so let's talk about Delta I SSBN, designed around the D9 missile complex. The D9 missile complex are the missile tubes, the missile battery, if you will, that's behind the sail of these Delta submarines. And again, they're shooting the RSM-40 vehicle. That's the thing that comes out of the tube. And then the NATO name is Sawfly. In 1965, the Project 667 Bravo is approved. So Yankee is brand new and still being built and in development when the Delta gets the go-ahead too. And the reason why they can do this is the Yankee is shooting a different missile than the Delta is. These ballistic missile submarines are not designed around the submarine first. They first build the rocket, then they build the launcher, then they build that launcher into a D9 missile complex, okay, D9 in this case, and then around that missile complex, that battery of missiles, they then design a submarine. So they do it from the rocket first, working their way out to the submarine. That's the process. And the person doing that is Sergei Kovalev. This guy is famous for designing all the nuclear SSBNs for the Soviet Navy. Like other SSBN submarines, Delta is designed for a specific missile launcher, that D9 missile complex, and it is packed into a complex of 4, 6, or more launchers. That's what a missile complex is. In the case of the Delta, it's a 12 pack. So you've got 6 and 6 in compartments 4 and in compartment 5, 6 and 6. And the reason for that, somebody had asked this on the Patreon while we were talking about this being our next topic. The reason why we're not doing 16 missiles like we did on the Yankee and we're down to now 12 is this missile's diameter is a little bit larger than the missile that the Yankee was launching. So they could not put as much in the same design. Because keep in mind, this is very similar to the Yankee with a larger sail, larger missile complex, same engine room, right? So you can't make a large missile or a large submarine just to get 16 missiles in it. You make the same submarine with the same designs and the same engine room, saving all this money and time, and experience, and just having a fewer missiles. All right, RSM-40 will have greater range than any previous submarine-launched ballistic missiles. This allows SSBNs to stay closer to home and in friendly waters. The Delta could literally hit its targets with the Mod 2 missile, the one after 1978, from its pier. It didn't have to go to sea anymore to hit targets in Europe and even hit targets in North America. It had a very long missile range, over 9,000 kilometers, which is more than twice the missile range of the Yankee missiles, or almost twice, not quite twice, but very close to it. So it throws a missile a long way. Very capable. Okay, so the Russian naming conventions, I added this slide at the last minute because I want to explain this to you guys, because we're going to talk about different names, but we're talking about the same missile. And it's the second one from the left there on the diagram. And it is the R-29D. If you ever hear that, that's the missile vehicle name. Okay, that's what we're talking about, the actual missile itself. Okay, the RSM-40 is what we would call the same missile if we were writing a treaty with Russia and America, or NATO and Warsaw Pact. We have this treaty out, and they were talking about RSM-40. You can only have 20 RSM-40s deployed at any one time, So that's the language that they use. The U.S. name, and this is unique to United States, not necessarily even NATO, is SSN-8. That's what we called it. That's what the Americans called it. Other countries did call it. I think UK called it that too, just for simplicity. But the NATO name, okay, so that we're all speaking the same language, was Sawfly. Sawfly was the name of the missile before 1978. After 1978, they still called it Sawfly, but it was Sawfly Mod 2 with the longer range, the 9,000 kilometer range. And then the D9 missile complex is simply the group of tubes that launch the vehicle R-29. Okay, that's it. So they're all kind of talking about the same thing, just one's a missile tube, one's a NATO name, one's a US name, one's a treaty name, and one is the actual missile itself. Hope that clears that up a little bit. All right, so they're being designed by the Rubin Maritime Design Bureau. This is the primary design bureau for all submarines in the Soviet Union and today's Russia. They still design submarines today. They began designing in 1901, so that's pre-Soviet Union. That's like Tsar's Russia. The Construction Commission of Submarines, or the CCS, is what the design bureau is derived from. They designed about 950 submarines so far, and that's going up constantly. I should probably update that number closer to 1,000 by now. And that's individual hulls. That's not types of submarines. That's individual submarines. So like the Typhoon had 6. So 6 of that 950 is Typhoon. Okay, so 20 submarine projects and vanity projects, or things that they can brag about, basically, is they did design the fastest submarine like the Papa, the deepest submarine like the Mike, the largest submarine, the Typhoon, the largest SSGN at one time was the Oscar, and the quietest diesel sub was the Kilo at one time. So a lot of people asked why I added quietest diesel sub Kilo, and how did I know that? So what I mean by this last statement is the Kilo diesel submarine is the bar, the measurement that every other diesel submarine is compared to. And yes, today there are some new submarines that are made by other countries like Sweden and Germany and Japan. Surprisingly, Japan has a great submarine now that are quieter than the 1980s Kilo. Okay, but that doesn't take away the fact that they did have the quietest submarine at one time. Okay, and that would be the Kilo. The Kilo improved, which is the new Kilo, really quiet. That thing, I think, absorbs sound instead of radiates sound. But diesel submarines today are so quiet, and those measurements, the noise measurements, are so secret. There's really no way to know in 2020 going forward who is the quietest diesel boat. Just know that they're all extremely quiet at this point. I hope that clears up the Kilo comment. All right, so R29 and its modification mod 2 is R29 Delta. Okay, so you say R29 Delta, you don't need to say mod 2 after it, but I wanted to make that very clear to you that Delta 1, Delta 2 are going to be throwing that white missile, second from the left, around today. The missile itself, R29, went operational in 1974. It's a 2-stage liquid fuel rocket, so it's potentially hazardous. You know, it's going to have a lot of risk involved with handling it and operating it, just like the R-27 did for the Yankee. It has only one 8 megaton warhead, so that's how it gets away with throwing it so far, is it's got one warhead and it's got a lot of energy behind it. It's 13 meters tall, 1.8 meters in diameter. The Mod 2 after 1978, 9,100 kilometer range approximate. And the accuracy is greatly improved with the Mod 2 to approximately 1 kilometer target circle. So that's a diameter circle of 1 kilometer. That's where the warhead vehicle is going to end up. And remember, it gets a mid-course correction in its suborbital flight to make sure it lands in that kilometer circle. So it originally deployed in 1974. It was a revolutionary onboard azimuthal astro correction system. That's the mid-flight correction system that previous Russian missiles didn't have at that time. The R-29 was the first one to have that. Okay, the R-29 missile complex, by the numbers, it is 40% larger than the previous missile complex on the Yankee, so a lot taller. You can see it looks like a big box sitting on the back of the sail there. The submarine hull diameter was also increased by about 20% from the Yankee. We're comparing this to the Yankee. The throw weight was increased to 1.1 tons, so that's how much force the tube can eject out the top, 1.1 tons. And reduced planned 16 missile tubes to 12 to fit the existing in the existing designs. They did not want to build a Yankee stretch and call it a Delta with 16 missiles. There really was no need to. You got 12 of these out there, especially under START treaty conditions, and that's all you need, 12 at a time. Plus, they're going to build like 18 of these. They're going to have a lot of Delta 1s. And in 1965, it's approved for use in Project 667 Bravo Marina. That's the missile complex, the tubes, the launchers that we're talking about, was approved in 1965. All right, so the Delta was built by Sergei Kovalev. We talked about him briefly. I wanted to bring this up to you here, where he is responsible for designing the Hotel, which is the original nuclear ballistic missile submarine that the Soviet Union had. He does the Yankee. He's going to do all 4 of the Deltas we're going to talk about over the next couple months. And of course, the Typhoon, which was, I think, the pinnacle of his engineering achievement. That was almost, the Typhoon is so complex and so large, and it works. I think he just did it on a dare, and he really demonstrated his engineering prowess by building something like that. That worked so well, they made 6 of them. Yeah. Very impressed with them. But today we're talking about the 667 Bravo Delta 1. All right, so where are we building these things? Well, we're designing them down in Admiralty Shipyard. That is where the Rubin Design Bureau is at. And we're going to build them for the Northern Fleet in the Northern Machine Building Enterprise, or SEVMASH. We're also going to build some at that infamous Pacific shipyard called Comsomol on Amur. And that is the one, we'll get into that a little bit later in the lecture. Remember, that's kind of the corrupt shipyard that is on the Pacific coast, away from the eyes of the Kremlin, and they kind of get away with things over there, including cutting standards. And sometimes that causes complications. But we will get to those stories. All right, let's talk about the Delta I project by the numbers here. You have a great shot from SaturnX here of a Delta I in a floating dry dock. You can see the two 5-bladed propellers. They would have these two 5-bladed propellers up into the 90s, and then a few that were still operational, there weren't many in the 90s, would eventually get 7-bladed right before they were scrapped. And then other Deltas will eventually, like the Delta IV, nothing but 7-bladed propellers. But before there were 7-bladed propellers, they had the 5. And the 5s are much noisier. They're basically surface warship propellers that they stick on a submarine because they can grab a lot of water and push it, but they're also very noisy in the way that they do that. All right, the length is 139 meters. The beam is just under 12 meters. That's the beam is the cross, the width at the widest point. Missile launch depth is 55 meters or surfaced. They can do either one. Test depth is 1,312 feet, and she can stay at sea for approximately 80 days. She has approximately 120 officers and men on board, 2 pressurized reactors, which is the VM4 Bravo, with 52,000 liters or 14,000 gallons of coolant in it. That's primary coolant circulating through it. The OK700 steam generators turning 2 GTZA 635 turbo generators. It's essentially the Yankee engine room. Okay, same thing. 2 5-bladed shafts, like I said. Possibly they could have had a 7-bladed shaft after 1990. They didn't necessarily all get that. Max speed was 25 knots with the 5-bladed propeller, and 12 R29 or R29 Delta ICBMs in the D9 missile complex. She had 4 53-centimeter torpedo tubes with 2 40-centimeter torpedo tubes facing forward. The Tobol B inertial navigation, that's the gyroscopic navigation that once they submerge, every little motion that they make is plotted electronically on a chart. And it slowly over time becomes inaccurate, but it's pretty accurate for a couple days. And they just routinely take a fix, that's what they call it, of where their actual position is, whether it's through the periscope looking at stars or other methods. They can even map the bottom with their fathometer and figure out where they're at. So either by looking up or looking down, they will narrow the error that the Tobol inertial navigation slowly gets over time back to a specific position, and then run a few more days with it or a few more hours, however long, and let the area of uncertainty slowly grow. But it's a great inertial navigation tool, Tobol, because it's not dependent on magnetic headings. So they can go across the pole and know where they're at. They can go down to the equator. It's not a big deal. They also have the Cyclone B space navigation, and that's again using astral fixes, very similar to what happens on the missile itself. Well, the submarine can do it too. They can raise the mast up. It looks like a little cone. It's right on the front of the sail. You'll see it in a lot of pictures, and that's the Cyclone B space navigation. The Mylonia Radio Complex Automatic Communications, that is the radio room, basically. It is a complex of different radios that they just call Mylonia. And it has a lot of automatic communication where they can, set it in mode and it will transmit and receive all the traffic. They don't have to type in initially they have to load all the message traffic, but once they load the message traffic into the computer, it will take care of the rest. The Kerch shark teeth sonar, very familiar with that. I've heard that so many times. The same sonar that's on the fast attack submarines, the Charlie, and what's the other one? Charlie. Okay, well, the same fast attack submarine sonar that they have, they also put on the ballistic missile submarines. They have a pop-up radio buoy. They fly it behind them like it's a kite as they go through the water, so they can receive launch orders without VLF antenna being deployed if they don't want to have it deployed, which is like a little cable they string out behind them that's like a mile long. So you don't always want to have that deployed. They can float this radio buoy and fly it like a kite up towards the surface and stay down at their, 55 meters or even deeper. And they have the autonomous digital computer, the KTS-VS, which is the automatic computer that can launch the missile tubes. We talked a little bit about that in the beginning. The missile tube launch procedure is automatic now. The valves are opening and shutting by themselves, all computer controlled. They have automatic hydraulic systems that, apply pressure when it needs to, rolls valves when they need to, and it's all hands off now, which is great. It's much faster, and there's less chance of mistakes. All right, construction is assigned to SEVMASH. Again, this is not the only shipyard, but this is where we're beginning our story, and this is where the first Delta I is built. And that is called the K-279. Keel is laid in 1970. She is launched and commissioned in 71, 72. In 1973, she completes her first at-sea deployment. And in 1973, the missile was not authorized for use. So they either went to sea with ballast weights shaped in the shape of a missile, just to fill up the tube, which is common. I mean, it is rare even today that any ballistic missile submarine from any country goes to sea with missiles in every single tube. And a lot of that is for treaty reasons. There are restrictions on the number of missiles they need and all that. But in 1973, they should not have been going to sea with a missile at all because it wasn't authorized. But you never know with the Russians in the Cold War or even today. It's so close to them being authorized in 1974, they might have went to sea with operational missile. I don't know. But they did go to sea. We know that. And then they came back. 1974, they moved to the Ostronovi settlement. I've marked it there on the map for you. It's very near Gromyka, which is a town in that area. It might even be the same. The settlement might be part of the Gromyka. Anyway, they provided electrical power because the Gromyka power plant had not been finished built yet in 1974. So they hooked up this submarine to shore power, and they provided electricity for the local inhabitants for a short period of time until the regular power plant came online and provided power for the town. So that was cool. That's something all submarines can do as long as the shore facility is designed to receive power from the submarine and not just give it. It's got to be a special connection. American submarines can do the same thing. We never really practiced it, but we talked about it. I remember whenever we would pull into Cape Canaveral, which is in Florida, talking about if they had a hurricane and the hospitals were on diesel generator, maybe we need to give them some energy. Those connections in Cape Canaveral could support the local hospitals and, high risk buildings and stuff. And so they did that for this small village, which was really nice. 1975, 76, they did 2 patrols. 1976, the dry dock, they found that the main ballast tank high pressure lines had ruptured in main ballast tank 3, and the damage was repaired. There's not a lot of description as to what ruptured, but there is a check valve that prevents seawater in the main ballast tank from coming back into the submarine and then filling up or getting into the high pressure air banks. Obviously, the high pressure air would eventually equalize and kind of keep it out, but you don't want water in your high pressure air lines because whenever you emergency blow, that high pressure air is going to expand rapidly and it will freeze the pipe solid, and you won't be able to emergency blow anymore if there's moisture in there. Well, apparently something had damaged the line, allowing moisture to get in. So had they done a high pressure blow, it is likely they would have froze the line. And that is part of why the United States Thresher could not recover from her casualty. She had frozen air lines as well. So thank goodness they didn't have a casualty that required them to use that system because it did not work in 1975-76 on those patrols. Okay, in 1977, an explosion occurred during a rocket launch, but it was determined that the rocket itself was at fault. And so they dry docked for repairs after that and some upgrades. All right, K-279 continued. In 1982, after she gets out of the dry dock and she's repaired, she goes on another patrol. In spring 1983, she conducts a missile patrol under ice in the White Sea. And that is really rare because the White Sea, as you can see there with my White Sea arrow, is, deep inside Russian territory. But with these missiles, they don't need to go very far. So they did a patrol in the White Sea. It's really hard to get into the White Sea as a NATO force because not only are there lots of Russian version of Sosis in there, that's a very high popular area for fishing, patrol boats. You're going to get caught if you're trying to go into the White Sea. So it was very safe for them to complete their mission in the White Sea. Let's see, December 1983, she dry docks again to replace some propeller blades. It's possible that she got 7-bladed propellers at this time, but that's kind of early for that. So maybe they just needed new 5s. It's not clear. In May 1984, on the surface at sea, a new crew member was throwing away some trash in the missile compartment superstructure between the hulls. So like I said, these submarines are 2-hulled submarines. You see how tall the missile compartment is behind the sail. It's tall enough for a person to walk around the tubes in there. So at sea, whenever they want to get rid of trash, they don't want to throw the trash in a bag and let the bag float around. That would give them away, right? So this new crew member, he's from Uzbek. I don't know if it's Uzbekistan, but he's an Uzbek, nation, because Russia is huge and has different cultures. Anyway, this new seaman doesn't speak Russian very well. And so he doesn't even have a rating because he can't read the Russian manuals. But he volunteered for submarine service. So they're putting him in the galley until he gets his Russian up to speed and he learns a job, and he'll eventually go on to do the job, right? That's the plan. So as he's working in the galley, he's told, hey, we're on the surface. We're transiting out to the dive point. Throw away this trash, dump it out in the missile compartment. And whenever we dive, the seawater will flush it out into the sea and the fish will eat it and it'll be fine. No bags. That's what he's doing. So he goes and takes some of the trash into the missile compartment and is, I guess, throwing it away, doing something where he's just throwing it around in there. And they're almost to the dive point. So one of the senior warrant officers goes to the hatch that goes to where you can walk around the missiles, in between the 2 hulls, and says, hey, we're all down in 5 minutes. We're going to dive in 5 minutes. And he gets no response. So he obviously thinks that the new crew member is not there. He's not responding to him. Well, the new crew member is there and doesn't speak Russian, and he doesn't realize why he's being yelled at. He's brand new. So he doesn't say anything. And then he kind of hides. He doesn't know what he did wrong. He's doing what he was told or what he thought he was told to do. He's throwing away the trash, and somebody at the hatch is yelling at him, somebody he doesn't know. Anyway, so they shut the hatch, and they eventually, 5 minutes later, dive the boat with the young crew member still between the primary hull and the secondary hull, trapped inside the missile compartment area there. And of course, he drowns. It isn't until hours later that they find out that he's missing. They sound the alarm. They're like, find this new crew member. And eventually it comes out that he was doing the trash duty. They surface again. They find the body and return him. The sad thing is that in the records, the ship's log, they simply refer to the young seaman as the young replenishment. And that may be a poor translation, but the young replacement. They don't even name him. And that might be because he's so young. Maybe they want to protect his family. I don't know. But they could have at least honored him by name in the ship's log. They did not. I thought that was not good. All right. So in 1992, after that incident, this is like 6-8 years later, she is finally removed from service. The first Delta I operational is taken out. And in 2004, her nuclear fuel is moved to long-term storage. All right, K447, the Kislovodsk. Keel laid 1971, launched in 72, and commissioned in 73. Look at that. Just banging them out now. Okay, so in April 1974, conduct a flight design test for missile systems. An oxidizer released toxic gas into the missile compartment. But this time there was no injuries. It has a very similar problem on the Yankee class. But this one they handled correctly. October 1974, so later that same year, they conduct a missile test from the Barents Sea, and it successfully launches all the way down to the missile range in the Pacific. So very long range missile test. Remember, the missile is just becoming operational in 1974. 1975, while submerged, the aft trim tanks were flooded and began filling compartments 8 and 9. So the way the trim tanks inside the submarine work is you have these trim tanks forward, and there's multiple of them, and you have trim tanks aft. And they have little vents. They're not pressurized tanks because they don't have a direct, well, some of them, I should say, don't have a direct connection to sea pressure. So if they have a vent and you overflow it, the water will start coming out of the vent and into the bilge. And that's what was going on. And they didn't realize it. They were flooding the engine room trying to trim the submarine and not understanding why the trim was all out of whack and they were slowly sinking out. Well, finally, the alarm gets called off and they correct the trim, but not before the submarine has a 25-degree up angle, and they're trying to figure out why. They just brought on way too much water, and then we're trying to compensate for it. And the submarine the whole time was getting heavier and heavier and heavier back aft, causing the nose to come up. Big mistake. Chief of the watch's fault. And I understand that. I mean, the chief of the watch is a high pressure position to be in, and he definitely got fired for doing that. Thank God he didn't sink the submarine. Okay, June 1975, same year, while in port, connected to shore power, the batteries were being charged over the weekend. And it's like Sunday morning now. The shore power is lost briefly before it's restored, like just enough to make the lights flicker a little bit. But what this does is it triggers the automatic electric system to charge the battery again, because it went to battery for a brief second and then back to AC power from shore power. So the batteries are like, oh, we need to recharge. And the watchstander, the electrician on duty, he's not sitting in port at his post 24 hours. He's just responsible while they're in port for the well-being of the ship. So he's not really in the wrong, but he also didn't realize that he needed to go turn off the battery charge. Well, because the ship is in a surface sitting by the pier lineup and it's just recirculating air, through the top of the sail down into where the people are, he's not in the special lineup that is designed to ventilate the battery well. Well, the battery well, while it's being charged, generates a lot of hydrogen gas. This happens to every lead acid battery. It doesn't matter if it's Russian or not. So as this charge that no one realizes is happening is going on and the ventilation's not in the proper lineup, hydrogen gas builds up in the battery well. And when you know it, an explosion happens. Now, it's not a huge explosion like you would see in Hollywood movies. It's like a little flash, like you're starting a gas stove or something. But it is enough to cause minor damage to the battery well and scare the hell out of the crew. They use the LOX fire suppression system, which is like the Freon fire suppression system, to put it out. I do have a little bit of issue with the LOX being Freon, but I have multiple sources telling me that they use Freon gas for putting out a fire, which is weird because if you cook Freon gas under pressure, you can create a poisonous gas. And it will put out the fire by displacing the oxygen, but you've also just made a very poisonous gas. Anyway, that's a little sidebar. They use the Freon fire suppression system to smother the fire by displacing oxygen, and that works. July 1975, the very next month, while at sea, low oxygen is sounded in the forward compartments. This is after they dive, and they're wondering what the hell happened. Well, they had broke out some fire hoses to put out the fire in the battery well, right? And they had all this water charged up, and they have high Freon in the compartment because they had used that to put the fire out. Well, whenever they drained the fire hoses into the torpedo room's bilge, a lot of the Freon dissolved into the water there, into the drained water. And they didn't pump the water overboard for some reason. So it sat there until they went underway again, fizzy with Freon. Now, while they were in port, in the ventilation lineup circulating air, the Freon that was fizzing out of the water was being taken off the ship. The moment they rigged for dive and went into a recirculation air mode, that Freon had nowhere to go. So you have all this water in the bilge, full of Freon, slowly poisoning the crew in the forward compartments, setting off alarms. And so they finally figured that out. They pumped the bilges dry. They get up to the surface again and they, recirculate the air like they're supposed to, pump the bilges dry, and it fixes the problem. But it shows how one casualty from a previous month can cause a problem in the future or your next deployment because you didn't finish the job of cleaning up after the casualty. They should have never left that water in the bilge for a month. Every bilge, if it can be dry, needs to be dry, just for safety, if nothing else. All right, so here are some common operating areas we see the Delta in. And this isn't just Delta 1, it's a lot of the Deltas. Up at the top, those are the Atlantic deployment areas, a lot around Greenland. The one on the top left is right off the coast of Canada, very, very close to the United States there. They did a lot of Arctic deployments because it was closer, it was easier to get towards America if they just went across the top of the planet. So they kind of deployed up in the Arctic region a lot. Now, on the Pacific side of things, which is coming up, we haven't got there yet, they do a lot of deployments in the Sea of Okhotsk and just south of that in the Pacific. And then, of course, the Bering Sea and North Pacific, all the way down towards Hawaii. Very common to see them down in that area, too. And, you know, being in these positions, they can hit all the targets in the United States and even, in the case of the Atlantic, even in Europe. So they've got their bases covered if they just go to these places. All right, so let's continue talking about K-44 Kislovsky. In June 1976, completed a missile patrol at the pier on the base. That's right, they could launch these missiles. And I have some great photos here from Saturn X for you of them doing missile launch tests, obviously missile launches, from the pier. They didn't have to go to sea. They could hit targets at their Pacific Missile Range, which is where these missiles are going, or anywhere in Europe, you know, in the United States too in some cases, depending on where the pier is. In 1978, dry dock for scheduled maintenance. That's just routine maintenance. Nothing really bad happened there. In 1980, went on patrol on opening day of the Olympics. That might have been a message to the Olympics. If you remember, the 1980 Olympics were high drama because obviously the Olympics historically are supposed to be symbolic of ending war and having friendly competition between nations. But instead, they not only do they participate in the Olympics, they put their new Delta I on patrol that day, just kind of as a symbol. In 1981, they test fire 2 missiles from the Arctic region. 1982, it goes into overhaul again, another dry dock period. And then in 1980, after the dry dock period to 89, they do 7 patrols. So they were beginning to get their momentum now. They're starting to do multiple deployments in a year, or at least one a year. In 1992, she goes back into dry dock and overhaul. In 1995, during a missile test, a pipeline ruptured in the missile compartment again, very similar to what happened back in the 70s. A crewman isolated the gas line and the launch continued. Now, this is something kind of unique to Russia. If a NATO nation ballistic missile submarine, even during a test, had any kind of casualty, especially a gas line, something to do with the launching mechanism, they would not even attempt to launch the vehicle. But in the Soviet era, you had to complete the mission regardless of, work through the casualty, even if it's a test, even if it's a serious casualty. So like the mentality in the American Navy is safety first. Whenever you're drilling and conducting weapons tests, if it's not war, you always have safety paramount to everything. Well, that is not how the Russians think. So they isolated, they fixed the problem, they proceeded with the test, and it worked. Even though they had this gas line rupture, the target vehicle reached the Pacific Range accurately. So good job to them for doing that. So between 1992 and 2002, that 10-year period, they do 4 deterrent patrols and conduct 4 torpedo test firings. In 2000, she goes through another dry dock period, but by then they're running out of money and she's getting old, so they remove her from service in 2004. And in 2015, the reactor is still in temporary storage, waiting to be moved into long-term storage. A lot of reactors by this time in 2015 are in long-term storage, not this particular one. All right, K-450, new submarine, still being built in Sevmash, still on the Atlantic side of the house. Keel is laid in 1971. She's launched in 73 and commissioned. In 1974, to 1983, she does 3 missile patrols. That's really low tempo. So what is probably going on there? She's probably doing some tests. Remember, they have these new communication systems. She could have been doing missile tests, although those are normally logged in the ship's logs. But most likely she was performing sonar, radio, navigational testing in the 70s and early 80s. She's dry docked for scheduled maintenance in 1983. Gets out in 86 and does 3 more missile patrols, about 1 a year till 1988, and is removed from service. And at this time, K-50 is now the model for the Delta I. She had no major incidents during her entire operational lifetime. All right, K-385, laid down in 71. A lot of these were laid down in 71. Sevmash, very busy shipyard. And keep in mind, Sevmash is also building Yankees. Okay, so they're not just doing these, just very busy time in Russian shipyards. She's launched in 73. There's no deployment data for the 70s. She definitely did deploy. I just don't have the dates. So I wanted to make a note of that for you here. She goes into dry dock in 1979. Comes out in 1982. So their dry dock periods are averaging 2.5 years or so. and does 4 patrols North Atlantic, including a missile test, in 3 years. So that's more than 1 patrol a year, ramping up the tempo slowly. She goes back into dry dock in 86, does 2 more patrols, 87, 88, is finally removed from service in 1994. So she's one of the youngest to be removed from service out of the out of the Delta I's. That's K385. K457. K457 keel laid December 1971, commissioned in 73. In 1980, we're jumping all the way up to 1980, conducted a missile test after surfacing through the ice. So that's a big achievement, is to surface through the ice, break the ice away, open the hatches, and then see how fast you can get your missiles off there. And they do that pretty quick. 1980s to 1982, they do 3 missile patrols in the North Atlantic region. It also includes the one, whenever I say North Atlantic region, I'm including Greenland, Norway, Barents Sea, even though they really didn't deploy there that much. And then, of course, the Arctic area. North Atlantic region simply means not the Indian Ocean. That's all I mean by that. Very, very vague. Okay, October 31st, 1986, K457 collides with an American submarine in the Atlantic near Bermuda. This is the same time that the Yankee is having her problems and sinking off the coast of Bermuda. It happens in the same month. It happens actually about 3 weeks after that Yankee sinks. So they know that the Augusta's in the area, and that's how some rumors got started about the Augusta being involved with the Yankee sinking, if you guys remember the Yankee briefing. But no, she was not involved in that. She was, however, unfortunately involved in colliding with K457 about 3 weeks later. K457, to her credit, continued her patrol. Okay, so the damage couldn't have been that bad, but for the Augusta, they had to return to port immediately. They had a lot of bow damage and some sail damage as well. But later on in her patrol, this happened at the end of October. In December, near the end of her patrol, she struck the bottom on return to port. So she has a little bit of bottom damage or bow damage now from that as well, and has to go in and get all that repaired. But the big thing here is, even though she had a collision, she continued her patrol. American submarines, I don't think, would have done that. 1987 to 88, she does 2 missile patrols before going back into a scheduled dry dock period, 1989. And 1997 conducts a demonstration rocket launch for some VIPs off the coast of Russia. And that's pretty common. What that is for, like, the Russian prime minister and some admirals come out. Maybe some satellite states, want to see a rocket launch. Excuse me. All right, 1990, she's removed from service. And in 2015, moved to long-term storage. Okay, K465, another submarine. This one keel laid in 1972, so they must have had all their shipyards filled by 1971. So 1972, the next year, they're building another one. Commissioned in 1974. In 1975, she tests the Cyclone B space navigation system. That's the big cone-looking thing that they stick up on a mast out of the sail. 1976 to 1982, she does 8 patrols in 6 years. One of those is in the Kara Sea, and I put the map up for you so you can see where the Kara Sea is. Very difficult to get to the Kara Sea, very far away from NATO-friendly waters. You have to go completely through the Barents Sea to get to it, or come across the top of the world. So they know it's a very safe bastion to put a ballistic missile submarine. In 1982, she returns to Sevmash for maintenance period, and in April 1982, while on patrol under the ice, she has a collision at 100 meters. The bow is damaged and the topside is damaged. It's determined that she hit the bottom of an iceberg keel at 100 meters. That's over like 330 feet. So some of these iceberg keels go very deep. And if you remember back to our Nautilus briefing, we found that the Nautilus was finding iceberg keels with its forward-looking high-frequency sonar down to 600-700 feet. And they couldn't go under them. They were so deep. They had to kind of go around them. Their first trip, the Nautilus's first trip to the North Pole, was derailed by these large iceberg keels. But they ran into one at 100 meters on April 1982. 1983 to 85, they do 3 patrols in 3 years. They return to Sevmash Shipyard for a scheduled repair period before coming out in 87 to 89. And in 3 years, they do 6 patrols, continuing to ramp up the tempo of their deployments. These are 60-day deployments typically. They could be extended to 80, but they typically do 2 months at a time and come back out. They will modify that schedule a little bit in the 80s and 90s, but for this haul, that's the tempo that they had. 1994, she's removed from service, and her reactor is in long-term storage as of now. Safely disposed of. All right, K460, keel laid 1972. She's commissioned in 74. In 1975, she conducts a missile launch test at the pier, just like the one we pictured in an earlier slide. In 1975 and 76, she does one patrol and records what she believes to be is an American submarine. And there's no reason to discount that. Maybe she did, because we were all up in their business during this time. In 1978 to 83, they do 3 missile patrols and dry dock for a scheduled repair period in 1986. In 1988, patrolling under the ice, she struck the top of the sail on an ice keel at 55 meters and ripped off one of her antennas. So it managed to damage the sail so much that it ripped off the protective covering, got into where the masts and antennas were, and they lost one of them. So that's a pretty significant collision. Ice can do a lot of damage if you hit it hard enough. It's not going to just give because you're a nuclear submarine. Water does not compress. Removed from service in 1995 and 2011, reactor is in long-term storage. That's not actually a really good example for ice because it's actually the weight of the ice that causes that damage, not that the water doesn't compress. But anyway, moving on. K472, the keel was laid in 1972. She was commissioned in 1974 and might be one of the most successful Delta Is to this point. She does 8 patrols in 7 years, from 75 to 82, before she goes into overhaul for a year and comes out and does 4 more patrols from 86 to 89. She's removed from service in 1995, and her reactor is safely stored in temporary storage in 2015. As of 2015. It's probably in long-term storage by now, but we don't have any records after 2015 for that. That's K472. No incidents. Just an operational submarine. Operated well professionally with no big incidents. All right, K475. Another one that was keel laid in 1972. Again, Sevmash Shipyard. We're still in Sevmash. Atlantic side. We haven't got to the Pacific side yet. They're building all these over there. And then she's launched in 1974. In March 1975, she collides with a Foxtrot diesel submarine during a surface transit. Both captains are deemed at fault. Both captains get in trouble. And then she has to go back into dry dock for repair after that. So they were just 2 submarines passing on the surface and they hit each other. The primary cause of the investigation found that they both violated rules of the road. So normally, you want to do a port-to-port passage, so you're on the right, and from their perspective, they're on the right, and so you're passing down each other's port side. Well, they didn't follow that, and they ended up hitting each other. So 1982 to 84, they do 3 patrols in 3 years. 1986, she goes into the scheduled overhaul period at Sevmash Shipyard. That's the same place that they were built. She comes out of that in 1988. And while on patrol under ice at a depth of 48 meters, so it's very near launch depth, she strikes an iceberg keel. Now, the captain had been advised before this time that he needed to follow procedure and be below 100 meters. That was the procedure at this time. But he ignored that. He stayed at 48 meters. And as soon as they hit something, he ordered a left full rudder instead of a reversing bell, which drove the sail of the submarine deep into the keel of the iceberg to the point that it got stuck. And they were there for approximately 30 minutes trying to get out of this iceberg submerged at 48 meters. They couldn't surface. They couldn't back up. They were trying to, get themselves out of it. Eventually, the ice in the keel of the iceberg failed, and their submarine suddenly rolled to port as the ice on that side gave way, and they were luckily able to get out of that ice keel. But they literally drove themselves into an iceberg so hard that they planted themselves inside of it. And because he didn't do a backing bell immediately, he couldn't do a backing bell later to get out of it. That could have been much worse. But luckily, the ice eventually gave way to them. They did have to return to port for dry dock and repairs. 1989 to 1992, they do 5 patrols, which is great, no incidences, and are retired from service in 1995. 2015, the reactor is still in long-term storage. So safely put away now. Really dumb decision by that captain in 1988. He didn't follow procedures. And then when the casualty happened, that was inevitable because they were under ice at such a shallow depth. He mucked it up again by not following the procedures for hitting ice. All right, K-171, keel laid in 1973, launched and commissioned in 1974. In 1976, she transits from the Barents Sea through the Atlantic, all the way down around South America and up into the Pacific, into her new home, Kamchatka Peninsula. So we finally have our first Delta in the Pacific Ocean. It's K-171, but she was built in submash. But that's okay. So she's over here now. So where's Kamchatka Peninsula? Here's a great view of it on the Pacific side of Russia, north of Japan, kind of west of Alaska. It's this big peninsula that comes down, and there's lots of shipyards and bases in and around the Sea of Okhotsk, which is the one to the shallow water sea to the west there. But two major submarine bases are at Pavlovsky Bay, which is up on the main peninsula itself, and then Krasnikov Bay is the main base kind of down on the tip. And that is about a one-day transit between those two bases. So they get basically a one-day head start on their patrol if they're out of Krasnikov Bay, and that's why they go there. All right, so continuing the story of the submarine after she arrives on December 1978, while preparing for a missile test in north of Japan, a feed water valve to the reactor compartment was left open. It was left open because they were doing a feed water charge while in port. So they have a pure water truck on the pier, and it's pure water, like, distilled water. So it's the purest water, and that's what they use for primary, for safety, right? Well, they take a bunch of this water with them underway in case they need it. They can always add to the primary loop, right? You got to keep that primary loop pressurized. They do it with feed water. Well, after whenever they were in port and they had finished filling up the feed water, they disconnected the hose, but they never shut the valve. So whenever they went out and they submerged, seawater is getting into the feed water system, which is really bad. It contaminates it. It's going to eventually become primary if they use it, and it's got salt water in it. And one thing about salt, any chemist out there, salt loves radiation. You get some radioactive salt, it'll be radioactive for a long time. So you don't want to get salt water anywhere near your nuclear fuel, but that's what they've set themselves up for now. And so they have seawater entering the reactor compartment because the valve's open, and it's just spilling into the reactor compartment now. It's not even going into the primary, so it's going into the bilge of the reactor compartment at this point because the valve's open. The reactor is shut down, thankfully, whenever this happens. Okay, they're working on the other reactor. They have two reactors. One is up, one is down. The valve is open on the one that is shut down. So they've got that in their favor. So they open up the reactor compartment and they start removing the water with buckets, like a bucket brigade. All the engineering watchstanders. There's 10 or 12 guys, 15 guys back there. And they're like, oh man, who left the valve open? Who's finger pointing? And they're like, all right, everything's cool. We're not going to report this. We're not telling control. The people driving the boat up in the forward part of the ship have no idea what happened here. We're going to get the water out of the bilge, and we're going to send it into compartment 8. That's the main engine room. Put it in that bilge. And with that pump, we're going to pump it overboard. And that way nobody has to get in trouble. Everything's going to be fine, comrade. Okay, so that's what they do. They bucket brigade all the water out of it until there's just a little bit of water left in the bottom. They can't get a bucket down there to scoop it out because it's just a little tiny puddle of water. So they're like, what we're going to do is we're going to shut the door. We're going to pump all that other water off like we talked about. And for this little bit of water that's left, we're going to turn the reactor on. It'll get hot. That water will evaporate. No more problem, right? So that is the plan. That's what they're going to do now. So they start the reactor up and the water just sits there. It's getting really hot in the reactor compartment. Temperature's going up, very radioactive, but the water's not evaporating. So they're like, oh, we got to go do something. Maybe we need a sponge or something. We just got to get this water. So while the reactor is operational, I can't believe they did this, but engineer Tapunov, Sharov, and a civilian contractor or civilian worker, Mr. Crashcook, enter the reactor compartment with it critical. I don't know why their hair didn't fall out immediately from the radiation, but it didn't. So this reactor's critical. It's really hot. They just want to get this little bit of water out. It's going to be in and out real quick. They dog the door shut behind them, which is a big mistake, and it kills them. They're in the compartment now with the door dog behind them, when that little bit of water finally does get hot enough, flashes to steam and pressurizes ever so slightly the compartment that they're in. But it only takes a little bit of air pressure to pin you in a compartment that cannot alleviate or equalize that pressure anywhere else. And they panic. They start banging on the door. They try to open it. They have watchstanders on the other side of the door in the engine room in compartment 8 looking at them, trying to use a crowbar to open the door, get some leverage, and just enough to let some air in to equalize the pressure so they can get these guys out. And they can't do it. Now, there is a small equalization pump in the bottom of both reactor compartments that they could turn on and lessen the pressure inside the reactor compartment that would eventually equalize and they could open the door. But who knows how long that would take. But in their panic, they didn't even think to try that. They're panicking, pushing, kicking, throwing their shoulders against the door, trying to push it out into or pull it in to the reactor compartment, and they just can't get it open. And they have to call it away. They're like, they tell control. They're like, we have a casualty back here. We had water in the reactor compartment. They tell them the whole story. And by the time they shut down the reactor, obviously, immediately, whenever they realize this problem, but it's too late. Those guys have been radiated to heaven and back. And they're all dead. All 3 of them die from radiation during this time. Heat exhaustion. It's over 100 degrees Fahrenheit during this time that is critical, but there's also radiation, and the radiation is what's killing them. And they are non-responsive by the time they get the door open. So a really sad story that was a simple mistake that happened in port. And had they simply, reported the mistake and, kept the reactor shut down and, cleaned up the water per procedure and just dealt with it like a casualty, it would have gone a lot better. But instead we lost 3 people, one of which was a civilian on a warship. Anyway, so obviously the missile test was canceled and they returned to port. Okay, we're not done with her either. K171 story continues. That's right, 1979 shows a low feed water in the reactor alarm. Yep. Remember that feed water we talked about? It's what, supplies the primary, keeps the primary loop going if they need it. Well, they have a low level alarm now going off on that system. The water evaporator that underway produces pure water and then goes into the feed system is not working. Okay. Or it was working, but it was in a closed loop. So it was making water for itself. It was literally boiling seawater, making fresh water. That fresh water was in a closed loop going back down into the seawater and being boiled again for 3 days, and nobody noticed. So they didn't have any new water coming into the feed system for 3 days. Well, once they figured that out, they corrected it and they continued with the missile test. But once the missile test started, that missile, after it launched, self-destructed 55 seconds into flight. So K171 can't catch a break. They're screwing up lineups. People are dying. Missiles are self-destructing. It's just a nightmare boat. A few years later, 1981, after leaving the pier for patrol, a fire breaks out in compartment 10. Compartment 10 is all the way at the rear end of the submarine. I mean, it's back there by the shaft seals. There's hydraulic plants back there, but there's also these electric motors that turn what we call spinners. Russians don't call them spinners. We call them spinners because that's what we do. Anyway, so the electric motor in one of these catches fire. And this is like as they're going down the river. Like they can still see the pier and the base. They're not very far. They have a tug alongside them and a fire in the engine room. Well, they put the fire out, but they don't turn around. They keep on going. So they decide that they're going to just keep on going to sea, and they go out and they do their patrol. Okay, so they're out on patrol, and a couple weeks into the patrol, the evaporator doesn't work properly. So they're operating the evaporator in manual mode, and the human operators are not as efficient as the automatic operation is, because the automatic operation balances itself out perfectly, so it's making the maximum amount of water every day. Well, with a human just checking on it every 20 or 30 minutes and making minor corrections to the pressures and levels, they're not as efficient. So they're not making enough water for the reactors. So one of the reactors suffers a depressurization in the primary loop. This contaminates part of the engine room with radiation. Going back to having the compartments equalized, they had the ventilation lineup in a way that if compartment 8 pressurized, compartment 9 and 10, going all the way to the back end of the submarine, would pressurize as well. So now they're not trapped in the engine room, but that means is that the radiation that leaked from the reactor, suffering a depressurization, is now in the entire engine room. So the entire watch team of 15, 20, however many people are back there, are all potentially contaminated. So they call it away. Thank God they're actually calling it away this time. The engine room is sealed, which that watertight door is normally sealed anyway, but they also sealed the ventilation, keeping the radiation from moving forward through the ventilation ducts and contaminating the entire submarine. For 6 days, the crew is not relieved. They are kept back there and making water manually until they have enough water to refill the feed tank, to fill the primary loop, and recover from this casualty. They only bring up one reactor, and it's not the reactor that depressurized. They leave that one alone until they can get back to port. But they get eventually one reactor back up online with enough feed water to get back to port. But they're not going back to port right away, comrade. No, we're only 3 weeks into this patrol. And even though we've had a fire and we've had this radiation casualty that potentially contaminated multiple watch tenders in the engine room, we're going to continue our patrol because that's what we do in the Soviet Navy. And so after putting the one reactor back online with just enough water to get them going again, they spend 30 more days on patrol, completing their nearly 60-day deployment. Yeah, that's the mentality we're talking about. Despite all the hazards and things that went wrong with K-171, they still completed their mission. It's almost as if they fear failing their mission more than anything else. And that's not a good mentality when you're working with reactors and radiation and nuclear weapons. You want those people comfortable in that work environment to tell superiors about casualties. Otherwise, you're going to have a bunch of secrets until something gets out of hand, like we've already seen happen. K-171, we're not done. She, in 1985, deploys just north of Hawaii, kind of what I alluded to earlier. So very not Southern Pacific technically, but she went very far south in her patrol area to be just north of Hawaii. In 1987 is her final strategic patrol, and then she pulls that one off without any problems. She's removed from service in 1995, which is a common year, by the way, for decomming a lot of these Delta I's. And in 2015, her reactor is safely in long-term storage, so she can't hurt anybody else. But what a crazy story K-171 is. This is a bad luck boat. This is a black sheep boat. We have lots of little nicknames for boats like this. But in each case, this was crew initiated, or crew actions and inactions made the casualty much worse. So you can't really blame the boat for a lot of things that happened. All right, let's move on to K-366. That keel was laid in 1973. Commissioned in 1974. She's the first Delta submarine to be built in the Komsomol on Amur River shipyard. And remember, this shipyard is the major shipyard over on the Pacific side of Russia that builds a lot of submarines for them. All right. In 1975, the submarine is based out of Krasnivnikov Bay. Remember, that's on the southern little island south of the Kamchatka Peninsula. She does 4 patrols between 1976 and 1981 without incident. That's great. In 1981 to 85, she dry docks for about 4 years, a little bit longer than normal. But like we said, this Amur shipyard, not as good as Sevmash. Doesn't have the track record. It could be craftsmanship, experience, a lot of factors in them just not being as proficient. It's a little bit longer of a dry dock period. But hey, the first submarine they built didn't have any issues. Okay, she gets out of dry dock, and in 1987, she patrols the Sea of Okhotsk, trying a new tactic for the first time called laying on liquid soil. And that is just the Google Translate version of what the Russians call this. And essentially, it is bottom sitting with your nuclear ballistic submarine, much like you would do in the Oberon's. But the Oberon's a diesel boat and is designed to do that. If you sit on the bottom with a nuclear submarine, you're very likely to get mud and silt into your main seawater systems that are always running to cool all the equipment that is associated with that nuclear reactor, and other systems as well, but especially the nuclear reactor. Excuse me. So that's why they don't normally sit on the bottom. So how they describe this tactic is they get near the bottom and then they trim the submarine so the nose of the submarine pitches down 10 or 15 degrees. And they slowly sink out until the nose touches the bottom. And they sit there using the bow of the submarine, touching the bottom, acting as an anchor, and just sit there with like a 10-degree down, which must make walking around the submarine a pain in the butt. if your rack is, you're either standing on your feet while you're sleeping or you're standing on your head while you're sleeping if your rack is facing forward and aft. But you have this 10-degree down angle with the nose of the submarine just touching the bottom with enough friction to keep you from being pushed around too much by the currents that may be in your area. But they call that laying on liquid soil. K366 successfully does this for the first time. So why is that important? Well, if you're not moving anywhere, obviously the screws aren't turning at this point. The engine room itself isn't making much noise. Your reactor coolant pumps are still running, and your 50 hertz generators are running, and your 400 hertz generators are running for system power and whatnot, but there's not much else going on. So you're about as quiet as you can be, as long as you're not damaging your submarine and rubbing it across rocks or something. But if this is on a sandy bottom, this is a very good tactic for hiding. Because remember, they have that floatable radio buoy that they can just let it drift up, because it's positively buoyant, and collect communication information while they do this laying on solid or liquid soil maneuver. And they do that for about a week. In 1993, they removed from service, and in 2003, the reactor is in temporary storage. I don't have an update after that, so we assume that it's in temporary storage here. But an interesting tactic nonetheless. The Russians are always thinking outside the box. All right, so let's talk about the shipyard. If you're familiar with the series, you've seen this slide before. But for everybody else that's new and maybe a little refresher, the Komsomolsk on Amur shipyard is a couple hundred miles inland along a river, the Amur River. So it's very secluded, away from any borders, and kind of just sitting there north of North Korea and Japan. And what they do is they build submarines. They put them on floating dry docks. They send them on the floating dry dock down the river, where they submerge the floating dry dock, and the submarine is free to go about its business, which is usually to a pier where it does testing. It doesn't do the testing actually in the river. So they'll check some systems, of course, before they take it down the river. But there's also pier-side testing that's done after they put it on the floating dry dock and it goes down. But anyway, there's some great pictures of it. It's a very busy shipyard, but it has a reputation of not doing very good quality work. And in some cases, they would not release a submarine onto the floating dry dock until they got paid more money. They were almost holding their own government, because this is a government-run shipyard, for ransom. So they got initial money to build the submarine. The submarine is now built, but they want a few more rubles, millions of rubles, however much, because of cost overruns and whatnot, inefficiencies in the shipyard, essentially. So it's not all corruption, like I may let it lead you on to believe. There's also a lot of inefficiencies, and every inefficiency costs time, and time is money when you're doing anything construction-wise, or just about anything really in business. So there are cost overruns that they want to be compensated for before they release these submarines to the Navy. And they usually get their money. Yeah. All right, so they also built K417, keel laid 1974. So look at this. The other submass shipyard, very busy, 1971, 72, 73. 74, we're building the second submarine here at the Amur shipyard. She is commissioned in 1975 and begins patrolling the Pacific in 1977. In 1983, she conducts a 4-missile salvo test, one of which, and it was tube 2, by the way. So they launched tubes 1, tube 2, which are the forward 2 tubes by the sail, and they launched tube 11 and 12, which are the most aft 2 tubes. Tube 2 did not launch due to an improper launch tube lineup. So it was either that automatic system failed, or they didn't have the system lined up in the first place for the automatic fire control system to launch the missile. But either way, they only got 3 of the 4 off is the point. 1983, the shipyard maintenance period is scheduled. She goes in and does that. She comes out of the shipyard and does 4 patrols in 4 years. And then she's eventually removed from service in 1995. Notice how 1995 is a recurring theme. That has a lot to do with treaty dates, like START Treaty and SALT Treaty and all these agreements, NATO and Warsaw Pact, or at this time, 1995 would be Russia and NATO. And so to meet these agreements, they don't need all these missile tubes. They don't need the Delta I anymore. So they're just retiring them rather than refitting them again. And in 1999, the reactor is cut out. I have no idea where the reactor is now. Hopefully somebody does. Okay, K477, keel laid in 1974. commissioned and launched in 1975. In 1977, after loading a missile onto Tube 12, it was overpressurized. So this is a crazy story. So let me back up. In 1977, she conducts a missile test with a missile that does not have a warhead. Test is fine, everything works. She comes back into port. This is in Vladivostok, by the way. So this is not the Kamchatka Peninsula. She's in Vladivostok, which is on the other side of the Sea of Okhotsk there. And she gets a missile that does have a nuclear warhead on it in Tube 12. That's where we're starting. This is a real missile with a real warhead and a real problem because they overpressurize it and the missile fuel tanks implode enough that some of the liquid fuel that's in there becomes pouring out. Okay, this should be giving you flashbacks of the Yankee casualty because that's how that went down. So this isn't new to them. They've learned to recover from this before. So what they do is they seal the tube. Of course, the missile's already in it. They've already loaded it. And they begin flushing water through it to keep the tube cool. Water comes in the top, is pumped out the bottom, and it's recycled in a closed loop. And mixed in with that water is liquid fuel. But there's enough water in the fuel mixture to keep it from combusting. But now what do? They have a nuclear missile that has chemical components that are trying to overheat and mix with each other, being cooled in a closed loop of seawater, salt water, and a nuclear weapon inside the missile tube. So that if there is a fire or explosion, there is a chance, there is definitely going to be nuclear contamination involved with the explosion. And they think that maybe there might be a nuclear explosion too. It might just blow up enough to compress the warhead and cause, a nuclear mushroom cloud. Now that's highly unlikely, but it is in the realm of possibility, they think. So they're like, well, what do we do with this? We're sitting here by a pier. We have a tube casualty and we can't recycle water forever. Or can we? Maybe this is our life now. Well, what they decide to do is they go out to sea. They go into the Sea of Okhotsk right off the coast to just deep enough water, and they submerge to 50 meters, which again is launch depth. Remember launch depth, 50 meters? Well, they go to 50 meters and they open that hatch up. In case it does explode, it will vent the explosion out of the submarine instead of into the tube, causing who knows how much damage. And sure enough, that's what happens. While submerged, the hatch open, the water and the fuel finally mix in such a way that the temperature rises, explodes the entire missile inside Tube 12, blowing the warhead out of the tube into the air and splashing down again, inside the Sea of Okhotsk. And all this happens under the observation of, support vessels that are around it trying to figure out how they're going to do this casualty. And what they do is they go over to where they see the splash of the warhead, because it's not that far away. They put a buoy marker there, and they're going to come out here with this submarine that you see here in the picture called the India class. And it has a couple of AS-2 deep diving subs there with it, and they're going to go down there and they're going to recover the warhead, which they do. The warhead was not destroyed. Opening that hatch, going to sea, submerging to 50 meters, saved a serious nuclear incident from happening. This is still a nuclear incident, but this could have been much worse. And they were able to pick up their own bomb, and who knows what they did with it. But that is the casualty of 477. That happened in 1977. That's the year Star Wars came out. All right, continuing on with the same submarine into the 80s now. From 80 to 83, she does 6 patrols in 4 years in the Pacific. In 1984, she goes into her scheduled repair period for about a year. So not a major repair, but a repair period. She comes out, and from 1985 to 1995, she does 11 patrols in the Pacific with no problem. Now, we've seen how these sailors like to hide problems from Admiralty, and if they can get away with it, they will. So there is likely things that did not go perfectly well in an 11 patrol period, but we don't have any record of it. So we just have to tip our hat to them and be like, good job, comrades. 11 patrols in 10 years, and you didn't mess up. Well done. In 1988, they did do the bottoming, laying on liquid soil technique for a week. They practiced doing that successfully. No problems getting off that. And that is a more tricky maneuver than you may realize. Trimming a boat with a down angle, simple enough. Trimming a boat with a down angle and then ramming it into the bottom without damaging anything, that's got a light touch. That takes some seamanship. So credit to them for doing that and not having any damage to the ship. In 1995, she was removed from service, and in 2003, the reactor's cut out. All right, K497, keel laid in February 1975, launched in 76. From 77 to 87, 12 patrols without an incident. Well done. Again, they're getting better at hiding these incidents, or they're getting better at operating their submarine. I'll go with maybe they're getting better at operating it. She goes into the shipyard repair period. Again, this is a no more built ship. So she spends 2 or 3 years in that repair period, comes out and does another 5 patrols without incident. At this point, I'm not buying it, but the records state that they did an entire service life of K497, 17 patrols, not a single incident. That's the official record. She's removed from service in 1995, and in 2015, reactor confirmed in long-term storage in Usteretsky storage facility. That's the primary storage facility over on the Pacific coast there. Well, that's where all these reactors are eventually going to end up. All right, K500 or K500, laid down in 75, commissioned in 1976. They're really cranking out these boats. I mean, you got to give it to them. It's about an 18-month, looks like, turnaround from keel laid to commissioning. So they've got the template down. Once they get 1 or 2 built, they just start pumping them out. So hats off to the shipyard workers. They are doing great work. In 1977 to 84, she does 9 patrols in the Pacific. In 1984, she finds a U.S. submarine while on patrol. And I don't believe this, but according to the ship's logs, they hear the U.S. submarine shoot a water slug from its torpedo tube. And so that is a simulated attack. Like, you don't know that water slug doesn't have an actual torpedo until after they shoot it, and you wait a few seconds to see if a torpedo started up. And of course, it's meant to scare the hell out of people if they actually did that. That is wildly outside United States submarine doctrine. They would never do that. But again, this is 1984. This is Cold War. Maybe we had, a cowboy U.S. captain wanting to screw around with the Ruskies. The other reason why you would never do that as the U.S. submarine is that would give your position away. So certainly you wouldn't do that. Anyway, the Russian Captain Kopykin surfaces his submarine with this U.S. submarine close aboard and radios headquarters that this event occurred and that he's preparing to counterfire if he is attacked. But of course, there is no attack. He doesn't counterfire, and everybody goes about their business. But he claims that the U.S. submarine shot a water slug at him. That's highly suspect. There's lots of reasons why that would not happen, but we're taking the captain, this is the Russian perspective of the story, so we're taking him at his word. In 1985, this is the next year, she pulls in for the shipyard repair period, scheduled repair, stays there for a little while, comes back out, does 2 more patrols in 1995 with 1 successful missile test during that period. In 2000, she's removed from service, and in 2004, her reactor is moved into temporary storage. All right, K512, honorary name 70 years of the Komsomol. Komsomol is Russian for the young communist. And it's kind of an honorary name. We've seen this name before on other submarines. And even the shipyard that built the submarine has the name Komsomol. Anyway, so the keel laid January 1976. She's commissioned in August 1977. Again, really good construction times. They are doing great. In 1979, they begin this 2-crew cycle, which is what the Americans do. And I think all of NATO ballistic missile submarines do this, where we have 2 crews on 1 submarine. And what that allows you to do is take the submarine out like literally twice as much. As soon as you can get it, refit and refilled with fuel and everything repaired and resupplied, you could take it right back out again. But you will wear down your sailors quickly if you do that with 1 crew. So they tried this 2-crew cycle, and the Russians do it in a 45-day deployed, 30-day import, 60-day deployed, 30-day import. And they do this 45, 30, 60 cycle over and over again. And they end up getting a lot more patrols out of their submarine. It works for them, just like it works for NATO. So from 1980 to 85, they do 10 patrols between the 2 crews in about 6 years. Really good. They're getting more bang for their buck. So they're seeing the 2-crew concept does work. And they do this on other submarines as well. And I'll try and point them out as they come up. But they didn't even really give this a shot until the end of the 70s, is my point. In 1988, she is officially awarded the 70 years of the Komsomol. Right there, I assume that's the 70th anniversary. Yes, of the Russian Revolution. That's what that is. In 1989 to 94, she does 6 patrols without incident. And in 1995, she's removed from service. Her reactor is in long-term storage, confirmed as of 2015. About the 2015 date, just to revisit that, these reactors could have been in long-term storage before then, but the confirmation that I have is dated 2015. So that's why I'm putting that date there. Could have been earlier. All right. K523, keeled late in July 1976, launched in 1977, commissioned October 1977, same year. In 1978 to 80, she does 4 patrols. This must be doing the 2-crew concept, probably 2-crew concept. She goes into dry dock in 1980 for 2 years, 2.5 years, and comes out and in 4 years does 8 patrols. So they're really getting a lot of operational time out of this K523. And notice how there are no incidents. It seems like by the time the 80s came around, they had finally learned their lessons, the hard way, it seems, to follow the procedures and operate your submarine professionally. Because it's so important that even the smallest oversight must be corrected immediately before it leads to something terrible. So they do 8 patrols in those 4 or 5 years. They go back into the shipyard in 1986. Again, this is all a scheduled, event. There's no casualty that causes this. This is just normal maintenance. And in 1989 to 91, 3 more patrols. She's removed from service in 1995. Reactors in long-term storage in 2015. One of the most successful Pacific Delta Is we've talked about in this entire lecture is K523. She's built quickly. She's operated efficiently, and she does all of her duties without any incident. Well done. All right, K530, keeled late in 1976. She's commissioned in 77. From 78 to 81, she does 6 patrols. Again, probably 2 crews. In 1985, while on patrol, came across a U.S. submarine and evaded her without indication of detection. And this is really the first time, I think, in any of the subbrief lectures we've done, where the Soviets detected the NATO submarine first, in this case, an American submarine, and got away without that submarine chasing after them or showing some indication that they had been counter-detected. The Americans, from the Russian perspective, were oblivious to the missile patrol boat. Now, some of you may be asking, why didn't the Russians stick around and record the American submarine? Well, if this was any other attack submarine like the Victor or the Akula or Charlie, maybe they would have done that because that's kind of in their role. But the primary mission of these ballistic missile submarines is to hide this missile complex. They got this 6 or 12 pack of missiles that they're moving around the Pacific chessboard. And their primary mission is just to keep it away from the Americans. And that's why they didn't hang around. But in 1985, apparently they got the drop on one American submarine. In 1988, shipyard repair period is done and completed, no problem. 1996, she does a successful missile test, well done. And in 1990, she is removed from service. And in 2015, confirmed her reactor is now in long-term storage. Also, look at this picture. The submarine I've been talking about, K530, is the one on the left. Look at the one on the right. Look how much bigger it is. That is either a Delta III or Delta IV. I can't read the brow name, so I'm not sure. But this shows you how much bigger each evolution of the Delta is. Delta II is bigger than Delta I. Delta III is bigger than Delta II, and so forth, all the way up to Delta IV, which is going to be the big one that we're going to get to very, very soon. All right, some final thoughts about Delta I, our first step in this journey of the Deltas and their great history. One, this is a fantastic design. They took the Yankee and made it work with a new missile complex, the D9 R29 Delta Mod 2 Sawfly missile. So even though they had to only use 12 missile tubes, they did that efficiently. They're pumping these things out in like 18 months, which is really fast to build a submarine, even today. And they're doing this back in the 70s. Well done to them. But, and this is a huge but, this is so important, poorly operated. We lost lives. Russians lost lives because they didn't operate their submarine safely. And this is not unique to the Delta. We've been seeing this as a pattern throughout the Cold War. Now, every nation has its mistakes. You can point to any nation and say, well, they messed up over there, and America included, but not to the level that we've seen in the Delta I or the Yankee or any of these other nuclear submarines. Russia is really going up into the 80s, struggling to operate these machines, and they're complicated. Just because you have a procedure doesn't mean you necessarily understand what you're doing. And that's a real problem with submarine sailors. You need to also understand what you're doing when you read the procedure and you perform that action. In your mind's eye, you need to know the whole system and understand what you're doing so that you don't make a mistake. Anyway, they did not have that level of familiarity and experience, and it showed. And they were also in a culture of fear, which again is not unique to the Soviet Union, but they were in a culture of fear where if something did go wrong, they were going to be hell to pay if they told anybody about it. So those factors played into how these sailors died, and it's a damn shame because they didn't have to. Anyway, wow, I get emotional about that because it sucks. Okay, so high tempo operation with 2 crew rotation on some vessels. This is the first time that they've really tried that, and it worked for them, so they continued doing it, especially on the Pacific coast. This missile had incredible range after 1978. Once they got to the R-29 Delta, which is the modified, improved version, they were getting over 9,000 kilometer range on this thing. So they didn't have to go to sea in some cases at all, but very far. They could hang around the shores of Russia and still hit targets in America, Japan, hell, all the way down to Vietnam if they needed to. And of course, Europe is right there on the Atlantic side as they come around the Kola Peninsula, which is why they didn't have to go down into like the mid-Atlantic. They did whenever they wanted to go around South America and they transited into the Pacific. Of course they did. And they had the navigational techniques to do that, but they didn't have to. And the closer they could keep these to Russian waters, the better it was for them. And that's how they operated. They had a very aggressive deployment locations near Canada and Hawaii. I was surprised that they operated in the Baffin Sea. I did not know about that until I did this research. So yeah, that's crazy that they got that close to Canada because, again, they didn't have to. But you know what? Who's going to think to search the Baffin Sea for a freaking Delta? I wouldn't have thought of that. So maybe that's what they were thinking. They're like, we're going to put this in this obscure part of the Canadian coast where no one's going to suspect this happening. Anyway, also, it's a good missile weapons platform. It's a good combination. It's a fantastic submarine. It's a fantastic missile. And they combine them together into, what is a good weapons platform. That's the military jargon whenever you combine, a mobile platform, whether it's a vehicle or a submarine or whatever airplane, and a weapon system. It's a good combination. They complement each other. And if they just operated it with more discipline, it would have been far more successful. As my one caveat is the crew. The crew messed this up. They could have done a lot better. From the captain on down, everybody. People died and they didn't have to.